That the sum from 1 to n of 2 over r plus 1 times r plus 2 is equal to n over n plus 2. Let's look at this proof. First, we're going to have to separate this in partial fraction. So, to prove this, you have to separate it in partial fraction. So, first thing we can do is we can say, well, 2 over r plus 1 times r plus 2. We need to separate it in partial fraction. Well, this is going to be equal to a over r plus 1. We know it's some constant over r plus 1. Then it's going to be plus b over r plus 2. All right, nice. Then we just need to form the LCM. The LCM of r plus 1 and r plus 2, that is going to be r plus 1 times r plus 2. Yeah, man, this is what we get. Now r plus 1 into this leaves r plus 2, so it's going to be a times r plus 2. Then we're going to have plus r plus 2 into this leaves r plus 1. So it's going to be b times r plus 1. Yeah, man, we're good so far. And of course, this is equal to 2 over r plus 1 times r plus 2. Nice and easy. 2 over r plus 1 times r plus 2. So of course, now what we're going to do is, this right here is just 2, so you can look at 2 as 0r plus 2. All right, so that means there's no r term. And so if you're to expand this part right here, equating the numerator, what we're getting is 0r plus 2 is equal to, that is ar plus 2a plus br plus b. Then what we're going to do is group our r terms. So grouping our r terms, that means 0r is equal to ar plus br. And so if we divide through by r, we get a plus b is equal to 0. Then grouping our constants, what we're getting is 2 is equal to, that is 2a plus b. So since this is what we get now, what we're going to do is solve these two equations simultaneously. So we have 0 is equal to a plus b, and we have 2 is equal to 2a plus b. So we're going to subtract the two equations. Subtracting them, what we get is 2 minus 0 is 2. And then what we get right there is 2a minus a, that just leave a and b gone. So that means a equal 2. If a equal 2, then that implies b equal negative 2. So what that means then is that all of this that we just found, that this part right up here, this is now equal to, just right now, that this is now equal to a over r plus 1, which is 2 over r plus 1, minus 2 over r plus 2. That's what it works out to be. Nice. So it's 2 over r plus 1 minus 2 over r plus 2. So continuing this question using method of differences, we can of course rewrite this now to say this is now equal to the sum from r equal 1 to n of 2 over r plus 1 minus 2 over r plus 2. That's what we end up getting. And then now we can just evaluate these summations quite easily, because we just can break it up as two separate summations as the sum from 1 to n of 2 over r plus 1. And then using summation law, we have minus the sum from 1 to n of 2 over r plus 2. Yeah, man, let's say a word. This is nice now. So now the sum from 1 to n of 2 over r plus 1, this is just going to be equal to, working out all of this, this is equal to plugging in the 1, we get, plugging in 1 first, you get 2 over 2, which is 1, plus, plug in when r is 2, this part work out to be 2 over 3, plus, plugging in when r is 4, r is 3 rather, 3 plus 1 is 4, so you get 2 over 4. And then you can continue all the way down till the nth term, and the nth term is going to be 2 over n plus 1. So you get 2 over n plus 1. That's what we get when we continue. Right? I should have put some more dot to show that it continues. So usually so then put plus, then you see some dot, dot, dot. We should have done that. We have put a plus, then some dot, 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 just to show that it continues. Minus, then now we'll put in the next part now, which is putting 1 here, and it starts off with 2 over 3, plus, put in 2, you get 2 over 4, and then we can just continue until, now the last term is n, but what happened to the second to last term? The second to last term is n minus 1. Put n minus 1 right here. You get n minus 1 plus 2, which is n plus 1. That becomes plus 2 over n plus 1. Yeah, man. And then the last term is just plus. The last term right here is just plus 2 over n plus 2. So now, of course, we can do our subtraction. And what we're going to get is this 2 over 3 cancels this 2 over 3. This 2 over 4 cancels this 2 over 4. All right. And then this 2 over n plus 1 cancels this 2 over n plus 1. And so what we end up get, that this works out to be 1 minus 2 over n plus 2. So that's what the final answer works out to be. But we can write this as one fraction. Write it as one fraction. This can then be seen as n plus 2 over n plus 2, because 1 can be rewritten as n plus 2 over n plus 2 minus 2 over n plus 2. Yeah, man, just rewrite it as one fraction. 1 is n plus 2 over n plus 2. Now, n plus 2 minus 2 is just n. So all of this works out now to just be n over n plus 2. There we have it. It's proven. Soft with a capital T. Soft. Soft. That's how we do method of differences. Nice. Sum from n plus 1 to 2n, this is going to be equal to the sum from 1 to 2n. This is the sum from 1 to 2n of r times 4r minus 1 minus the sum from 1 to n. So the sum from n plus 1 to 2n is the sum from 1 to 2n minus the sum from 1 to n of this expression right here, r times 4r minus 1. So now let's evaluate the sum from 1 to 2n. So first, before we evaluate the sum from 1 to 2n, the sum from 1 to 2n, well, let's find the sum from 1 to n first. All right, when you find the sum from 1 to n, the sum from 1 to 2n is easier to find. All right, so let's go ahead and find the sum from 1 to n. Now, the sum from r equal 1 to n of r times 4r minus 1, this can be expanded to give us r times 4r, that is going to be the sum now from 1 to n of 4r squared minus r. Yeah man, 4r squared minus r. And so what that means is that this works out to be equal to 4 times the sum, 4 times the sum from 1 to n of r squared minus the sum from 1 to n of r, minus the sum from 1 to n of r. So all we have to do now is plug in. This is going to be now 4 times the sum from 1 to n of r squared, sum from 1 to n of r squared. So we plug in r as sum from 1 to n of r squared. Remember, this is 1 over 6n times n plus 1 times 2n plus 1. So that's what we plug in for, the sum from 1 to n of r squared. So we have this. Then, of course, we're subtracting now, subtracting the sum from 1 to n of r. And the sum from 1 to n of r is a half n into n plus 1. This is minus a half n times n plus 1. Now, you know my style already. Since this one have a fraction of 1 over 6, I'm going to rewrite this as 3 over 6. Instead of saying a half, rewrite it to 3 over 6, because that makes it a lot easier for us. Oh, if we rewrite it as 3 over 6, we can factor out 1 over, we're going to now factor out 1 over 6n. We factor out 1 over 6n times n plus 1. And what we're left back with when we factorize it is, when we factorize that, we're left back with, so we factor out this, we're left back with 4 times 2n plus 1. And 4 times 2n is 8n. And then 4 times 1 is plus 4. So left back with 8n plus 4 in here, minus, we'll factor out a half, 1 over 6n into n plus 1, we're left back with minus 3 here. We are left back with minus 3. So that means all of this works out now to just be 1 over 6n times n plus 1 times 8n plus 1. 1 over 6n times n plus 1 times 8n plus 1. So that's good for us. Nice. So that means that in order to find the sum from 1 to 2n, we replace n with 2 right here. All right. So if you're to write down somewhere, so let's write it down somewhere. Let's write it down in black. So you could then write hence. You could write hence. Hence the sum from 1 to 2n of r times 4r minus 1. You could then just write that this works out to be equal to, this part right here works out to be equal to 1 over 6 2 times 2n, because you replace this n with 2n, so it's 1 over 6 2n times 2n plus 1 times, replace this n with 2n, it would be 16n plus 1. That's how you do this question. So that would be the sum from 1 to 2n. If you want to simplify, you could say a 2 right here. cancel out a 2 from that 6 to leave 3. So this is 1 over 3n times 2n plus 1 times 16n plus 1. And so, in writing the final answer, so we can write that this works out to be equal to, we saw that this was 1 over 3. We got 1 over 3 n times 2n plus 1 times, I think it was 16n plus 1, 16n plus 1, and then we're subtracting, this was 1 over 6n, we were subtracting 1 over 6n times n plus 1 times 8n plus 1. All right, now here's the beautiful thing. Now let's see how we can simplify this. To simplify this, I first noticed that this is a 6, this is a 3. So I'm going to rewrite this as 2 over 6. I'm going to rewrite this as 2 over 6. And you may ask, so sir, why? I'm going to rewrite this as 2 over 6 so I can factor out 1 over 6 easily. If I factor out 1 over 6, n, because both of them have n in common, if I factor out 1 over 6n, I am left back with 2n plus 1 times 16n plus 1. So I'm left back with 2n plus 1 multiplied by 16n plus 1. And then I have minus 16n plus 1 minus, then I factor out 1 over 6n, I'm left back with n plus 1 times 8n plus 1. Left back with n plus 1 times 8n plus 1. That's what I'm left back with. So since this is what I'm left back with, all I need to do is just simplify inside that bracket to get an expression for this. So simplifying what's in the bracket, I have 1 over 6n times, now expanding this bracket, this time this is 32n squared. Then this time this is 2n and 16, that's 18n. 32n squared plus 18n. And then 1 times 1 is just 1, so we get plus 1 minus, now n times 8n, that's minus 8n squared, minus 8n squared. Then n times 1 plus 8n times 1, that's minus 9n. And then we have 1 times 1 is 1, then the minus make it be minus 1. Put a minus 1 here. So finally what we're getting is, this works out to be 1 over 6 times n times, in this bracket now, 32n squared minus 8n squared is 24n squared. That's now 24n squared. Then you have 8n minus 9n, that's plus 9n. And that's your final answer. 24n squared plus 9n. If you want to write this even prettier, you could factor out an n to write this as 1 over 6 n squared multiplied by 24n plus 9. That looks a little bit prettier. You can leave it as this, 1 over 6 times n squared times 24n plus 9. And that's how you do that. So